Oh yeah, 100%. That's kind of the deal, right?
Everyone okay with that? We cut them off after more than 8.
All right, we're gonna
No. 8 is enough.
enable the preview. Let's see a preview real fast of everything. Okay, let's hit start recording. All right, so it should be recording right now, hopefully. If not, we'll find out, but wait.
Do you want me to check some YouTube thing to see if I can watch it streaming over here just to
Yeah, make sure it'll show up on if you look at my YouTube channel. Just look up Stacy Devino. It should pop up, or I can get a link for you. Just a second. Oh yeah, I'm pretty easy to. Oh snap! Do you see everything? Do you see all the things?
I do see all the things. Yeah. Although I think when I start doing, it'll probably take over both of my screens, so I might not be able to see anyway, unless I guess got another computer to join the Hangout, which we do.
All right, let's make sure. Continue. Okay, cool. We'll just do all of the things. I think it only likes it when I run. I want to make sure that the screen recorder's going, but let's run this as this piece and that. Continue. And we got that piece. Okay, continue. Start preview. Okay, we will stop the preview. Recording. We'll just do. All right. Well, you know what? As long as it's got that piece going, so we'll stick with that for now. We'll trust that YouTube's being nice. All right. All right. So, why don't you get started?
Okay. All right. Well, good evening, guys. Thanks for coming out. Can you guys hear me? Yeah, great. Okay, so a couple of things you should know about me before we get started. One thing that I hear often when I give talks is that I talk pretty quickly. So if that happens, please let me know. Just, say, hey, like, slow down. We're not trying to watch this on 2X or whatever, right? And the other thing that you should know about me is that I love Lord of the Rings, probably like way too much, to the point where actually when I was in college, I would find people who had never seen the film, and then I was, all right, we're going to watch this together. And since I can't erase my brain and watch it as though it's the first time, I'm going to watch you while you watch it. Don't be creeped out. I just want to experience it again vicariously through you, right? So I love Lord of the Rings. And because of that, there's going to be some, some Lord of the Rings. There's the guiding metaphor of this whole thing is going to make a reference to Lord of the Rings. So let me go ahead and share my screen and we can get started here.
Sorry, I messed up by touching stuff. There we go.
No, you.
That was all me.
All right. Okay, can you guys see that?
Yes, we can.
Great. Okay, I'm not actually going to do a full screen presentation because I want to see your beautiful faces while I'm talking. But the title of the talk is Keeping Up with Dagger and DI, Dependency Injection. And so, okay, here's our first Lord of the Rings reference here. So, oh, wait, I have to do full screen or the animations aren't going to work. All right, hold on. There we go. Okay, so yeah, this is a scene. I don't know how many of you guys are fans, but yeah, this is a scene where you've got Gimli, like the kind of short, stocky dwarf dude, and he's trying to keep up with Legolas and Aragorn, and they're trying to find Merry and Pippin, two of the hobbits that have been captured by some orcs, like in the first movie. And there's this kind of running joke that Gimli is really slow, and so he's having a hard time keeping up with these other, the elf and the human dude. And I kind of feel like sometimes, as engineering, we're kind of like Gimli, and then maybe we've got marketing and maybe the CEO. They're out front, right? And so they're running ahead of us. They have all these ideas for features. They're visionaries, and we're just trying to keep up. And so that's kind of what I mean when I'm talking about keeping up with dependency injection and Dagger. I see both of these things as tools that help us keep up as developers with the business. And so here's what I want to talk about, the questions that I want to address tonight. The first one is, what is dependency injection? Then we're going to go into, why would I want dependency injection? Why would I want Dagger to do dependency injection? And then how do I Dagger? And then finally, how exactly does Dagger help me keep up with the business? So let's go ahead and get into, what is dependency injection? Now, the way that I like to explain dependency injection is, if you're, just a healthy human being, you depend on water to continue existing, right? And the way that you get that water is you just kind of reach out and grab it. And that's actually a way that a class might actually get its dependencies. So in this case, we have this human class, and it depends on a water object, and we're just newing up this water inside of the constructor. So that's not dependency injection, but that's one way that we might get dependencies. So if you're not so healthy, as a human being, what will happen is they'll hook you up with this, this drip here, and they'll inject some water inside of you, right? They'll inject the water dependency inside of you. So what that would look like in code, kind of going back to our class, instead of newing up our water instance in the constructor, it would actually get injected as a parameter, right? So that's kind of my, strange analogy for explaining dependency injection, but that's what it is. Okay, so now that we kind of have an idea, any questions about that before we move on? No?
Yeah, I think we're good.
Okay, great. Okay, so the second thing is, why would we want to use dependency injection? Well, I've already said, that we want to use it so that we can keep up with the business, but that's not really helpful. So let's break it down a little bit. There's really two things. First thing is dependency injection allows us to leverage object-oriented code for faster, cleaner implementations. And the second thing is that dependency injection is really crucial for allowing us to leverage tests to ensure that our changes don't break anything. So let's dive a little bit deeper, specifically on the object orientation part of this. And in order to do that, I want to bring up this guy right here. Does anybody know who this is? I'd be really impressed if you knew just from the picture.
You got me.
Here we go.
Not quite. Okay, so this is Alan Kay. This is the guy who coined the term object-oriented. And this is what he says about programming and object orientation. He says that any particular implementation is making pragmatic choices, and these choices are likely not to be able to cover all of the cases at the level of efficiency and richness required. This is standard object-oriented programming lore. We need to have different ways of dealing with the same concepts in a way that does not distract the programmer. So he's talking about polymorphism here, but let's look at an example really quickly of what he's talking about. So I work at a smart lock company, and our smart lock, the way that it works is you have your phone with you and you walk up to your door and you just touch the lock on the door and then the door will open up. That's kind of the standard mode of working with the lock. But there's another way where you can control your lock by going to this lock dashboard. And you'll see, the screen pop up, and then you can press this big button here to lock or unlock your door. Now, if we look at the code for this screen, here's our lock dashboard fragment. And you can see we're inside of our onCreated view here. And what we're going to do inside of this fragment is we're going to new up a BLE connection. That it's just an object that represents the connection between our phone and the lock. Now, when we new up this connection, we're not doing dependency injection. We are basically hard coding a particular implementation inside of our lock dashboard fragment. And this implementation, as we'll see, is not really going to cover all of the cases that we need, just like Alan Kay says will happen when we're depending on a particular implementation of something. And just really quickly for the rest of this method, so what we're doing is we're going to initialize the connection, and then we're going to set up our click listener so that we can lock and unlock our lock when we press the button, right? So this code works fine when we are only going to communicate with our lock via BLE. But what if, and let's fast forward a couple months, what if we also want to communicate with our lock over the internet? And this is actually a feature that we built later on at Unikey. You can see here I'm highlighting this part, this toggle here, where you can either talk to your lock through BLE or you can talk to your lock through the internet. So you can actually lock your lock. Like I could lock, if I had a home in Dallas, I could lock it from here if I have the app. And so now we have kind of two different cases or two different implementations of this BLE connection. And we can see if we look back at this code again, that because we've newed up a particular implementation of this BLE lock connection, we won't be able to basically easily swap between a BLE lock connection and an internet-based lock connection. So we've locked ourselves into a particular implementation. On the other hand, if we got rid of this newing up of a lock connection and we instead injected that lock connection object into this fragment, then what we could do is at runtime, we could switch which implementation of a lock connection we want to use. We can either use a BLE-based lock connection or we could use an internet-based lock connection. And what's really neat about this is that our code to manipulate the connection and to send lock commands doesn't actually change. So this is exactly what Alan Kay is talking about. We need different ways of interacting with our concepts or different implementations in a way that doesn't distract the programmer. So in this case, distracting the programmer means we don't have to change the code at all. We simply have to wire up our objects differently with dependency injection. So that's one advantage of using dependency injection. So that's one thing. The second thing is that if we're using dependency injection, it really allows us to leverage tests to ensure that we're not breaking anything when we make changes. And to kind of illustrate this point, let's start by asking you if you guys know who this guy is. Anyone? Ooh, I think I heard it. Yeah, somebody said Kent Beck. Excellent. Yes, this is Kent Beck. This is the guy who popularized TDD and was one of the original signatories of the Agile Manifesto. And he tells a really interesting story about the power of automated testing while he was working on a project called YCache. And here's the relevant kind of piece of that story. So he's talking about a new feature that he was asked to implement on the project. And here's what he says. So the trick now was to make space for the new functionality without breaking anything that already worked. After the addition of a few unimplemented operations, the bulk of the tests passed. By the end of the day, all of the tests were passing. In 2 days, the potential market was multiplied several-fold. And basically what he's talking about here is they added the capacity to handle different currencies in the application. And by adding those different currencies, they basically became an international company and project. And so the tests there were really, instrumental in helping them move quickly. And a part of writing those tests is that you're going to have to use dependency injection in order to mock things out and stuff things out. Fun fact, so the project that Kent Beck is talking about here is called YCache. And the person on his boss on the project is a guy named Ward Cunningham. Some of you might be familiar with him, but he invented the wiki, but he's also the guy who coined the term tech debt. So that's the history behind that term. The reason the term exists is because Ward Cunningham was trying to explain to his financially savvy project owners why he can't keep writing crappy code. And so the tech debt metaphor spoke to them because they happen to be working on a financial application. I thought that was interesting. I hope you enjoyed that. I can't see your faces, so I don't know. Maybe you're like, yeah, I already knew that. Okay, so in sum, that's why you would want to use dependency injection, right, to keep up. So we're done there. Now, why would we want to use Dagger to do dependency injection? Because I just showed you, dependency injection without Dagger, where we were just passing something into the constructor. So in order to kind of see why we might want to do that, let's go back to the lock dashboard screen here, and let's think about the dependencies that we need to exist inside of this lock dashboard. So first, we have a lock dashboard, and if you're using something like MVP, you might need a presenter that's going to be injected into that lock dashboard, and that presenter in turn depends on, let's say, a lock's repository that abstracts the data source that abstracts the particular data source that the lock data is coming from. And that object might in turn depend on, I don't know, like a database and maybe a loader manager if you're still using loaders and you haven't moved over to live data or anything like that. So if we actually look at the code for this, there's kind of a fair amount of boilerplate that we have to write. So first we have to grab our context, and we have to use that to new up a database. Then we have to use that to new up a locks repository, and then we have to finally use that to new up a presenter. Now, so this isn't really like the interesting code. This isn't what we're interested in trying to do inside of this lock dashboard. All we're doing is kind of building up our object graph. Now, what we can do in order to kind of clean things up if we want, or if we're kind of reusing the same code in multiple places and we don't want to duplicate, is we can extract this object graph creation code into a factory class. And that's fine, I guess. But what Dagger is it's a replacement for these factory classes that implements the dependency injection design pattern without the burden of writing the boilerplate. So that's kind of the value proposition for Dagger, and I think why it's pretty compelling for dependency injection. So what you wind up with is, if you go back to this code, instead of kind of polluting your code with this boilerplate to assemble your object graph, with Dagger you can just make it look like this. And this is actually like the best case scenario. It might be a little bit more boilerplate-y because this API is actually in beta right now for Dagger 2. But I hope you can kind of get the gist of like, how much code it could save. This is a simple example, but if you have a more complicated object graph, you really could save a lot of code by leveraging Dagger. So that's why you might want to use Dagger to do dependency injection. So now that we've hopefully I've sold you on why it's worth doing, you might be wondering, well, how do I Dagger? So if you look at the documentation and the user guide for Dagger, you're going to see like a lot of terms kind of crop up and concepts, and it's kind of overwhelming. There's just a lot of different things that you're like, what's going on here? And so instead of trying to dive into all of these things, I just want to give like a high-level overview of what Dagger is about, and maybe a way of thinking about how to organize all these different concepts. And so I think if we just go back to the question, how do we Dagger? And if we zoom in specifically on like, okay, Dagger, like why is it called Dagger? Well, okay, so it's called Dagger because it's actually, there's an acronym here. And the acronym is DAG, Directed Acyclic Graph. So they're talking about, it's kind of like a pun, I guess, or like it's an acronym describing the dependency graph here. It's a directed acyclic graph. So let's look at that more specifically. What does that even mean? So again, let's go to our lock dashboard screen here, and again, let's think about the different dependencies that are going to, that form the object graph for that screen. Now, if we just kind of tilt this, we see that it kind of looks like a tree, right? Like maybe like the white tree of Gondor or something like that, right? So So yeah, it looks like a tree. And really, I think a helpful way of thinking about all the different concepts in Dagger is that they're really about creating this dependency graph, this tree-looking thing. And there's really only two overall concepts that you need to know. The first thing is that you need to think about the roots of the tree, and the roots of the tree are created by components. And then everything else basically maps onto the rest of those concepts that I listed on that other slide. And don't worry, we'll get into that in a second. But let's talk about components. So here we have this kind of the root of the tree highlighted. And again, components are what create the injected roots of the object graph. So, let's go back for a second. So the lock dashboard, that is the thing that is at the very root of this object graph. And it's the thing that all the dependencies are trying to get into. And the components help us do that. So here's what a component looks like. It's just an interface, and with the exception that you annotate it with a component annotation. And all you're doing is you're going to add a method called inject, and it's going to take in a lock dashboard. And so when we pass in that lock dashboard, the fields on that lock dashboard are going to get injected with the things that we need for that lock dashboard to do its job. So here's what that looks like inside of the lock dashboard. So here we are inside the lock dashboard. We're inside on create view, and you can see that we can create this. Oh, it says lockless component. Sorry, that should say lock dashboard component. That's confusing. But you can see that we can create this component using a static method that's generated by Dagger, and then we call inject on that component, and the presenter is the presenter that's annotated with @inject is injected inside of that lock dashboard. Let's see. There it is. So yeah, sorry about that. My slides got stuck there for a second. So, okay, so that's, yes, that is that. Oh, one thing I wanted to mention here. So when we create that interface, that lock dashboard component interface, what happens is that Dagger actually generates an implementation of that interface. And so when you call Dagger lockless or Dagger lock dashboard component.create, it's going to return an implementation of that interface that knows how to get a presenter inside of this lock dashboard. So instead of having all of this code, you wind up with just one line of code here. Now, this won't actually work because all we've done is we've told Dagger how to basically, we've only handled this root of the object graph here. We need to handle the rest of the object graph. And before we kind of talk about how to do that, I just want to make sure you guys are with me. How are we doing? Any questions?
Everybody good? Everybody good?
Yeah.
Anybody have questions?
Anybody have questions?
Okay.
Uh-oh, okay. Well, train's moving on. So we've talked about, we talked about how to get, this is the root of the object graph, and in order to do that, we get our components. So we've talked about that, but we don't know how to get the rest of these nodes in the object graph here. So let's talk about how we could add this presenter. How can we tell Dagger how to create this presenter? Well, it's actually pretty easy. So if we have a class here that defines our presenter, all we need to do is add an @inject annotation to the presenter as constructor. And this basically, this is all that Dagger needs to know in order to construct that presenter and add it to the graph. So now, Dagger knows how to inject a lock dashboard. We saw that with the components already. And with the addition of that @inject annotation, now we see basically Dagger knows how to construct the presenter and add that to the object graph. Okay, so ideally, all of our objects would, it'd be really easy to add them to the object graph where we could just do like an @inject on the constructor. Like it'd be nice if we could do that with the locks repository and the loader manager and the database, but it's never that easy. And here's why. So if we think about locks repository, let's say that it's an interface. Well, in that case, there's no constructor for us to put an inject annotation on. So how do we tell Dagger how to construct this thing? And let's take another example. Let's say we want to add an Android database to the object graph. Well, again, like this is third-party code. We don't have access to the constructor here that we can just add an @inject annotation on. So we don't, how do we handle that? And the answer to this is, basically modules. So modules have methods on them that you define that know how to add these tricky objects to the object graph as nodes. So when we're looking at a database, if we want to know how to add that, if we want to know how to tell Dagger how to construct that and add it to the object graph, what we're going to do is we're going to create a module to do that. So let's look at the code for how to do that. So it's pretty simple. We're going to have a class here, and we can see that it's annotated with module. And next, we can see that it has a method that's annotated with provides. And basically, the provides annotation tells Dagger, hey, if you want a database, it's going to look at the return type of this method, and it's going to say, okay, call this method if you need a database. And then, oh, whoops, went a little too fast there. So that's how that works. If you have a database, or if you have an object that you can't just do an @inject on the constructor, then you can create this module and you can annotate a method with that provides, and that basically tells Dagger how to construct that object and add it to the object graph. So now we have this, this database object that can be added to our dependency graph, and we can see here at the last line of the provides DB method, we're returning the database that we want to actually add to the object graph. Okay, so oh, whoops, slides out of order here. Okay, so yes, so you'll notice here that we have a SQLite open helper inside of our provides method. And you know that if you want an Android database, you're going to have to get this helper and call get writable database on it. Now, I left out the details of how this helper was constructed because we really shouldn't have to think about that inside of a module. What's really neat is that as long as Dagger knows how to construct the object that you need inside of your provides method, you can actually just move it to be a parameter of that method. So what will happen here is Dagger will say, hey, do I know how to create a SQLite open helper? Yes. Okay, great. I'll create it, and then I'll pass it to your provides method, and then you can use that thing to get whatever dependency you're trying to provide in that method. So that's a pretty neat thing. Okay, so the question that you should be asking yourself now is like, okay, I have this module. How do I actually tell Dagger to use that module? Well, in order to do that, we go back to our component, and what we're going to do is we're just going to add. There's a component, or there's an annotation parameter here, modules, where we can specify which module we want that component to use. So, so now, once we've done that, Dagger knows how to build the database object. And so if we just kind of sum things up, Dagger knows how to build the lock dashboard, how to inject the dependencies in that, and knows how to build a presenter. And it also knows how to build a database. Okay, so how am I doing on time here? I think what am I, like 20 minutes in?
Yeah, you're doing great.
Okay, great. I'm just trying to decide if I should skip some stuff. Okay, so I think since we have some time, let's talk about how we could tell Dagger to add this locks repository to the object graph. Now remember, the tricky part about this is that this repository is an interface. And so, okay, so in order to do that, we're going to go back to our module. I don't know why this is called locks list module. Sorry, this should be called lock dashboard module. And what we're going to do is we're going to add a method. It's going to be an abstract method, and it's going to bind. It's called binds locks list API service, and we'll break this down in a second. But the important thing with this new method to focus on first is that there's a bind annotation. And basically what a binds annotation means is that you're going to tell Dagger that this return type, I want to teach you how to build this type of the return type of this method, so the locks repository. And in order to build that type, what you're going to do is you're just going to actually build what's passed in as a parameter, which is this cached first locks repository, and you're just going to treat that as if it's a locks repository. So basically, this is a way of not depending on a concrete implementation of locks repository, but still teaching Dagger what particular implementation you need to add to the dependency graph. So that's how binds works. That's a little bit tricky, but it's really not strictly necessary if you're getting started with Dagger. It just helps you eliminate with some more boilerplate. So if that doesn't make a ton of sense, don't worry about it. We can maybe tackle it in Q&A or something like that. And you can still get away with doing Dagger without doing that. But with that being said, we've kind of talked about how to add this locks repository to the object graph. And so the last thing that we need to talk about is how would we add a loader manager to the object graph? Now, the tricky thing about a loader manager, if you think about it, is loader managers are only available inside of activities and fragments. And so it would be kind of difficult to write a Dagger module and a provides method that returns this loader manager. Like, how would we get a hold of one to return it? And so there's a way of solving this problem with Dagger, and it's called a binds instance. So let's look at kind of our component creation code here. And instead of just creating the code straight away with the static method, what we can do is we can grab a builder off of the component, and then we can pass in the loader manager that we want to be a part of the object graph. Then we build up the component and inject the presenter inside of the lock dashboard. So that's how we would actually use this binds instance. And that's how we would basically add an object to the object graph that is only available when the component is being created. And so it would be kind of awkward to try and implement it inside of a module. So in order to kind of use this binds instance trick, we'll go back to our component, and we'll add a builder. And again, we're just writing an interface here. And then we're going to, so we're adding a builder, and we're going to annotate it with component.builder. And then the important method here of that interface, this is kind of where the magic happens, is going to be annotated with binds instance. And this tells Dagger, hey, whatever I pass in as a parameter to this method, this is going to be added to the object graph. So once you've kind of created this builder, then you're good to go. You can kind of write this code where you're going to build up your component, you're going to pass in your loader manager, and then you'll be good to go. So with that, we've kind of covered how that object would get added to the object graph, and now we have a story for how we would add the presenter, the locks repository, the database, and the loader manager. So we can just kind of have our code here. We don't have like a ton of boilerplate where we're building up the object graph. We just build our component and then inject our presenter inside of the lock dashboard. Now, if we want to get really fancy, and I'm not going to get into the details on this, we can use some of the newer Dagger 2 APIs that are available in beta right now. And if we leverage that, then we actually get to get rid of the builder and the component and all that stuff, and we can just say Android injection.inject this, and it automatically build up all of those objects and then inject the presenter inside of the lock dashboard. So again, what we wind up with is, I think, a lot cleaner than this. Again, instead of building up the object graph manually here, we build up the context, then we build up the database, then we build up the locks repository, then we build up the presenter. Instead, we can replace all that with just this one liner. So I think that's pretty neat. Any questions before we move on?
Yay or nay?
No?
I actually
Go
had a
for it.
question from earlier, I forgot. For when we're looking at the components and we're trying to construct the components and what the generated class that is building that component out, is it the
Yes.
component with Dagger appended to the beginning? Is that always the case?
Yes, that's right. That's right. It is, yeah, Dagger is always going to be appended to the beginning. And the trick with, I don't know if you guys have ever used auto value or any of the other libraries that leverage annotation processing. Retrofit is another example. The trick with all of these libraries is that you're basically declaring an interface, and then there's an annotation processor that generates the implementation, and then there's some sort of naming convention that lets you get at the generated implementation of the interface that you declared. And so that's what's going on with the Dagger components, but it's the same thing with like auto value or I guess retrofit doesn't really follow that pattern, but yeah, that's what's going on there. That's a great question.
Awesome. Appreciate it.
Yeah, no problem. Any other questions? Okay. Oh, wait, do we have one?
Oh, no, I just said we're good.
Great. Okay, so that kind of covers, how do I Dagger, kind of at a really high level overview. And so let's move on to kind of the last piece of this. So how does, Dagger really help us keep up with the business as devs? So if we think about our object graph here and the different pieces of it, I think we can pretty easily imagine a case where we might want a slightly different object graph. So let's think about this, this database object, for example. If we're writing a test, we might want our test to be fast. We might not want to actually talk to a database, or we might not want to have to actually deal with populating a database before the test starts and kind of deal with all that nonsense. So wouldn't it be nice if we could basically swap out that database with a fake database? Well, if we're using Dagger, this is actually not too difficult to do. And we can actually do it in a way that doesn't really make our code really dirty. So if we start with our locked list component, which remember, this is the thing that knows how to create the injected roots. If we start with this and we basically subclass it, sorry, there's an animation there. So there's a change there that I want you to see. But if we subclass the locked list component, which should be called the locked dashboard component, I'm sorry, that's really confusing. But if we subclass that and we install a different set of modules, so we're extending it here. And then if we install a different set of modules, so before it said locked list module, now we're using a test locked list module. Then what we can do is that the test locked list module will actually, the provides method for the database will return a fake database instead of a normal one. And what's nice about this is that, once we've made this change to our component, we actually don't have to change our code in the locked dashboard that much in order to leverage this slightly different object graph. So what I've shown you here so far, this kind of hard coding the component constructor inside of the fragment, this isn't really best practice. Typically what you would do is you would actually have the fragments or the components inside of your application class, and you would grab the component off of that. So once you've actually made this change, oh, sorry, let's break this down. So you're going to get your application, and then you're going to get the locked dashboard component off of the application. And once you've made this step where you're not hard coding the component inside of your locked dashboard, what you basically can do is you can swap out your components for testing purposes without actually having to modify your code in line here. And the way that would work is you could use a separate build variant that has a separate application subclass that has this test locked dashboard component that you would just grab off here. And then you could use that to inject into your locked dashboard and do your tests without actually relying on a real database implementation. Now, the story for, let's go back here, one more thing. So the story for actually changing, if you recall correctly, there's kind of 2 points that I made about using dependency injection and Dagger to help you keep up. The first point had to do with testing, or the second point had to do with testing. The first point had to do with just being able to change out the implementation of interfaces at runtime. And the way that you do that using Dagger is it's the same exact thing that you do for testing. You're going to extend a component, and then that component that's a subclass is going to install different modules which have different objects that you want in the object graph, and then you're good to go. You don't actually have to change your code in line in order to get different behavior. And this achieves what Alan Kay was talking about, where you can have different implementations without, you know, distracting the programmer and muddying our code. So this is, you know, how Dagger can help us keep up. So yeah, that's kind of, yeah, hopefully kind of with these tools with dependency injection and Dagger, we'll be a little bit less gimly, you know, and we'll be a little better at keeping up with the business as we're deving. And that's my talk.
Awesome.
Okay, let me turn off the screen share. Okay, any other questions or feedback? That was one of the benefits of giving a talk here, right? Is you guys can tell me what I messed up.
So you know where the last build have this test? Can you hear me?
Yeah, I can.
I can manually hold the
Basically,
camera.
last slide where you have a test class that extended your other class, and that way you could just
Right.
use that. How do you? Where does that come in? If you actually want to run a test of a fake database or whatever. The code. I think I missed it.
No, you didn't. I was a little hand wavy there. So let's see. Maybe what we can do. Well, okay. So I think what you're asking is like, how do I actually get that test component? Like, how do I actually leverage that? How do I switch it out in a clean way? Is that what you're asking?
Yes. Yeah.
Okay. Yes. So okay. So basically, the gist of how that would work is you would use a build variant. So you could have a, you know, like maybe like an espresso build variant. And that build variant can define its own Android manifest, right? And once you've defined your Android manifest inside of that build variant, then you can define the application subclass that build variant will use. You feel me?
Oh, okay.
And so that application subclass can expose the different component that will be used inside of the class that you want to inject. Does that make sense?
Yeah.
Fantastic. Any other questions? Okay. Do we have one more?
No, I'm just moving it, like panning it back and forth. I'm the Vanna
Okay.
White situation right now.
Oh, I appreciate it.
I'm a
Say feedback-wise, I like the Lord of the Rings analogies. Kept it interesting.
Oh, good. I'm glad. Yeah, I tried to put more in there. I wanted to get a picture of Gimli drinking beer instead of the water analogy for explaining dependency injection. But believe it or not, it's kind of hard to find a picture of that. So I just had to go with boring water.
That's my only priority in life right now is finding it.
It's finding that picture. Is that what you said?
Exactly.
Well, I appreciate it. Yeah, if you find it, send it along, and maybe I can use it in like another version of this talk.
I mean, Balmer's Peak is real, so.
Well, great, guys. I guess that's it, huh? I mean, no more questions. I should say I guess I should say we're hiring at Unikey. I gotta plug that. So if you're interested in hanging out and working on some Dagger stuff, let me know. We use a lot of Dagger, so we actually have the way that our business is set up. It's horizontally integrated, so we don't actually manufacture smart locks. What we do is partner with lock manufacturers. So for example, we have a product with Quickset, and so what this winds up leading to is a lot of white labeling, and which is why Dagger is really important for us, because we need to have a way of wiring up our object graph in a different way so that we can get different behavior without having spaghetti code everywhere. You feel me? So we use Dagger a lot, and it's pretty fun. So if you're curious about the testing stuff that I was talking about, they have a pretty good testing guide on the Dagger docs that you can take a look at. I can drop a link, or you'll find it if you go to the docs. It says user testing guide, I think. So.
Why don't you give us a little bit of feedback as to why Dagger? versus some of the newer stuff from the Kotlin side, and what your thoughts are
Yeah.
on other injection libraries that are out there now.
Yeah, that's a good question. So I think the big library that you're probably talking about from the Kotlin side, I think it's called like Kotlin or something like that. I don't know how to pronounce it. But as far as I can tell, and I've only spent maybe 5 to 10 minutes looking at this, the big differences between Dagger and Kotlin is that Dagger is actually going to create the code that wires up your object graph at compile time and actually validate. It's going to validate that your object graph is correct at compile time. So if I guess I'm not going to share my screen again, but if you think back to the slide with all the different objects on it, if you don't teach Dagger how to build one of those objects, it'll fail at compile time and tell you, hey, you're missing this dependency. That's incredibly useful, especially as you think about, like, if you have kind of complicated object graph, or if you want to model your entire object graph for your entire application inside of Dagger, it's very useful to have that compile time feedback. And as far as I know, Kotlin does not provide that. It's all happening at runtime. The other thing that is kind of a big difference between Kotlin and Kotlin is with Dagger. Remember when we talked about how to add the presenter to the object graph? All we had to do in order to do that, and this is the easy case in the majority of cases, was we just added an @inject annotation to the constructor. And so that's really nice because we really don't have to write a lot of code in order to add a lot of objects to the graph. I don't think that's the case with Kotlin. Again, I think you are going to have to write some kind of code in order to add any object to the object graph, even if it's first-party code inside of your code base. As far as the other libraries go, so maybe Dagger 1 or Juice or I think Pico, there's something called Pico container. These are all kind of earlier generation dependency injection libraries. So there's not really, as far as I can tell, there's not really a reason to use them. Dagger 2 is kind of the new hotness, if you will. So there's not really a reason to use Dagger 1, or Juice or any of those other things. So. All right.
Awesome. Well, if you want to just say hello or tell us something about yourself at the end that you think we should check into, or what you've kind of personally up to that you find interesting, that would be wonderful.
Oh, okay, great. Yeah, let's see a little bit about me. So, you already know that I work at a smart lock company in downtown Orlando. I've been there almost 2 years now. Let's see. I'm actually, the way that I always talk about my background is that I'm a wannabe philosophy professor turned wannabe tech entrepreneur, which is just a fancy way of saying that I studied philosophy as an undergrad and then as a graduate student, and then realized that I didn't want to be poor. And so then I got into tech and started, programming. I took some classes. I've actually been programming since high school, but I took some classes when I was in grad school. And yeah, really kind of interested in the tech startup scene. So I've kind of tried to work for different startups in Orlando and hoping one day that I'll have the opportunity to start my own thing. Yeah, so that's a little bit about me. I guess I'm on Twitter. My handle is PhilosopHacker, and my blog is Philosophical Hacker. So that's if you want to check out my blog or whatever, you can do that. I don't write as often as I used to. I might actually post a written version of this talk, but I write a lot about testing, and kind of architecture and RX Java. I have some stuff on there about that. So yeah, I'm super interested in anything that helps me go faster as a developer. So that's what I tend to write about. Is my head really big there? Is it blown up on this massive screen? Is that what you're looking at? I feel like you guys.
Yeah, pretty much. I mean,
pretty
like
much.
150-inch.
Oh man. Yeah, this isn't.
Oh wait.
you want to get a real time situation of it? Do you want to see how
Yeah,
big
yeah,
you
I
are on a screen?
Oh my!
snap.
That's not
Very
good for my ego.
big.
That is not good for my ego. You know, I feel like the dude from. Have you seen V for Vendetta?
Wait,
The
just so you
Chancellor?
can see the perspective.
Wow. Yeah. That's not good for the ego. But I feel like the Chancellor from V for Vendetta. You remember that guy? He's like yelling at them. Ah! Anyway, okay. Well, guys, yeah, thanks for inviting me. This was really fun. This is the first time I've done something like this.
Oh, awesome. All right.
Well,
Cool.
thanks, and we will find a way to get you your fancy
Awesome.
mug.
Swaggerific.
I'm actually
Amazing.
I'm flying to Orlando in about 3 weeks.
GDG
So bring it.
mug from GDG Dallas. You
Wow,
are
that's awesome.
Orlando?
Yeah, like I'm actually flying into Orlando in 3 weeks. So
You're kidding. We should get coffee.
yeah. So
Get that mug.
Why don't you bring him? He'll bring you a mug. He'll bring you a mug. It'll be that kind of that kind of meeting. You got to meet a man about a mug, right?
Yeah.
Yeah. Really, you're meeting him for coffee. He just happens to get a mug out of the deal, right? Like.
Right. No, that sounds great. We should meet up.
Yeah, I'll figure out some time to do that.
Cool. Yeah, I mean, no pressure, right? If you're busy, but I'm just saying. Yeah, I'd love to meet up.
It is recorded.
Oh.
Yeah. So we'll figure out how to do that, and then we're gonna do a wrap for everybody here in the audience. So we'll switch back over, get your giant head off of get your giant mug off of the screen, so we can give away a giant mug. See what I did there?
Wow. So high on the puns. So high on the puns.
So, does everybody see their name up there? Like all the names that were written at the top, everybody else scanned through. Does anyone not see your name up there?
So I saw my name up there. There's Matt T and then Matt. Is that the
Yeah, I put Matt T. There was a Matt that registered. So I put Matt T. Okay. Is there another Matt?
You got 2 entries.
That's
Yeah, I didn't want
That's Matt T. Then.
Or is Matt Dupree? Is he on there?
Oh yeah, maybe that's the other Matt. So he's already getting one, so I'm gonna get rid of that. Okay. Everybody else sees the name? Okay. I'm gonna spin. If it's somebody who's not here, we'll spin it. So don't worry about that. Must be present to win. Oh. It's Ivan.
Oh, nice, dude. Way to win.
There you go. Here's your mug. Congrats. Awesome. Thank you for coming to GG. We've got a whole bunch of those, so we're gonna keep giving those away. I guess just every one a month. We'll go through them pretty slowly, so we should have enough for a little while.
Well, how many did we order? It's like.
We ordered like 70. Those are.
Yeah, that's true.
the 2 out of
Oh,
the
you don't for we had what, like I ordered 160 for the women tech makers thing. We gave out. We had like 120 people there. I was really glad we over ordered.
Yeah.
But,
Yeah, we still got 20, 30 left. So
yeah,
coming. It's not unlikely.
that's like a year's supply.
Yeah.
Yeah,
at least for the next year. And if you speak, you automatically get a mug. So you're guaranteed to get a mug if you speak. Just to.
And you also will get a special prize from my magic box of prizes of your choice.
I got a bookmark from you.
See?
There's a
Magic
hard
box
work
of
for it.
prizes. Yeah.
Cool. So thanks again to Matt for presenting.
Awesome. All right.
And
Well, we'll say
My pleasure.
bye.
so we'll say
Yeah.
bye. That kind of concludes